Next, we are discuss on the how we classify the soil. Okay, this is soil is a product of weathering. It's normally on the top of the our cover our earth. So the top layer is soil. Is weathering products. It normally consists of minerals and then weathered rock fragments. They call it regolite. Sometimes organic matter, and then gases, water, and living organism. Okay, so this is soil. So soil is deposit can be either as a residual soil or the transported soil. So look on the residual soil. What is a residual soil? Residual soil is develops in situ. Okay, in situ. So and characteristic is depend on the parents, which is the bedrocks that they are derived, called parent rocks. So residual soil deposit is commonly in tropical country like Malaysia. We have very thick residual soil. So for example, like this is a tree on the top. So this is the residual soil. So we have another layer here soil, but this is a weathered material. Normally on the top here is called residual soil. Okay. We classify as residual soil. Here we call that weathered material. Okay, what is the difference between residual soil and weathered material? We'll discuss on next subchapter. So in weathering qualifications, this weathering grade is we are classify based on the weathering classification system. So this classification is divided into 6 units, 6 group. So this classification system adopt residual soil based upon their material decomposing grade, weathered granite or volcanic rocks. So normally residual soil is on the top of the top layer of this weathering grade. So in terms of weathering grade, we are classify this weathering based on numbers. We call that number 1 until 6. So 6 here is referred to residual soil. So normally is 1 is referred to fresh rock. So normally fresh rock is there is no sign of weathering. Yeah. So what is sign of weathering? Is color. So meaning this rock is not changed their color. Still remain the color still remains the same. So in between here we have weathering 2, 3, 4, and 5. So for 6 here, what is a residual soil mean here is in situ. It's not transported, which is this soil is formed in situ place, and then this is the most important texture. The original rock's texture is completely destroyed, so mean that here we done is quite difficult to, if you see the residual soil, it's not easy to know what is the parent rock. So that's why in soil investigation normally we do trenching, what something like that, or borrow pit, try pit, sometimes try pit to to see the next layer of this profile. So the top layer normally is weathering grade 6. So we have make a dig for the trial pit to see the weathering grade 4 or 5 or 4, because the grade 4 and 5, so normally their rock texture still preserved. So based on the rock texture, we easily can identify type of rocks, the type of the parent rocks of this material, of this soil. So to understand this, we have a few type of testing. We're using a rebound hammer, Smith hammer. Start time we will use the slick test. So and then sometimes you can using the hand penetrometer. So okay, what is that? I can show you the pictures. What is the Smith hammer style hand penetrometer? So for grade number 5, this rock texture can still preserve, but rebound hammer value is 0, still is 0, and then this material is readily slip in water. Okay, so mean that this rock, if you have this sample, you put in the jar of water, this soil will be dissolved in water. Okay? A second grade number 4, which is highly weighted rock, they is classified as they have value of in low Smith hammer up to 25, and then this not ready slip in water. So meaning that if you put that sample in water, that sample still remain the same, and then and the penetrometer up to 250 kilopascal, and individual grain can be plucked from the surface, meaning you can take out their minerals. Okay? So if you can take out that mineral, means all this thing is easily to excavated. Yeah? You can use a machine to excavate this material. But when you go deeper here, grade 3, you can have a bit slightly difficult to excavate because their material is quite high. So the Smith hammer bound up to 25 to 45, and the material is not friable, and then the material is completely discolor. So mean that normally is like granite. This is referred to granite, only granite and volcanic rock only, not for the sedimentary rock. This is classification is only valid for granite and volcanic rock. We have a difference for sedimentary rock. So this is only for igneous rocks. Okay, for this igneous rock, you saw this, for example, granite. Granite is, color is light gray. So if they say completely discolored, mean they are reaching to brown or yellow. Yeah, oxidation happens. So if you have slightly weathered rock, grade 2, you only discolored along discontinuity, means you have a rock mass only along the discontinuity, only this area is weathering, the color change to yellow or browns, and then the middle here still remain fresh. Okay, so ribbon and Smith hammer up to 45, greater than 45. So you can use the geological hammer to, but you have to use more than one blow to break that specimen and the sample. So this is an example tools that you can use for these weathering investigations. You use Smith hammer. Yeah, you can use hand penetrometer like this. You can use slick test. You put in your sample in jar. You put water. So if you readily slip in water, is grade 5. Yeah. Rock texture. What means rock texture? If grade 6, your rock texture, you cannot see the rock texture. This is example of rock texture. You can see this alignment of mineral layer like this. So if we have still present, you can see this layer like this. Yeah. So this rock texture still preserved like this. So another type of weathering that they are referred to the proportion of soil and boulders. So for example, here for grade 6, there is none of them. You have boulders. So soil derived to in situ weathering 100% is soil. So if you go into grade 5, about 30% is of, only less than 30% have rocks. You have rock core here. Rock core here refer to grade 1, 2, 3. Yeah. Grade 4, 5, 6 is considered as a soil. 1, 2, 3. So this is another type of classification is based on this quantity of rocks, grade 1, 2, 3. So for weathering grade 4 is referred to 30 to 40, 50% of rocks, and then for grade 3, 50 to 90, and then here not more than 90, then here 100% is rock. So this is another type of classification of weathering. So this is about another type of soil is about transported soil. So we have discussed residual soil. Now we have discussed on the transported soil. In transported soil, they are referred to this deposited that the soil transported and then accumulated and they transported because of erosion, transported by water or wind, and then or by gravity. So and then this rock deposited on top of residual soil or sometimes on bedrock. So we have a few types of the transported soil. We call that colluvium. Then this is second is alluvium. Third we have glacial drift. So for colluvium is referred to soil that transported because of the gravity. So the material is slowly moved down the slope, creeping, and then deposited at bottom of the slope, okay, or at the toe of the hills, okay. And second type we call it alluvium. This is sediment transported soil that deposited by stream or river. And normally this because this sediment is transported by water. So what happened is this material, the transported material is depend on the uh, velocity of water or energy of water. So normally the deposition of this sediment is in strata or in layer, which is what happened is the sorting between the particle or sometimes silt, sand, gravel or clay depend on the energy of this stream or river. So it's stratified. The keyword here stratified in layer. So it's not happen to colluvium. It's not in layer because this is a creeping process. So it's when it's creeping, it's mixing between the particle. So another part is called glacial drift, also because of the glacier. Also this one is the characteristic of the glacial drift is not stratified. Normally is mixed like this, like colluvium. This is example of colluvium. You can see here is a mixture of two sides like this. So it show this is transported by this is a mixture or mixing of a size of rocks because of this creeping. This alluvium, this is you can see the strata. We have a coarse layer, fine layer, sand layer like this. Even you can see the cross bedding here. See, you can see the cross bedding. So that's the transport. The water is flowing to these directions, deposited here, and then another energy here. So high energy, low energy, high energy, low energy, high energy, something like that. So this is alluvium. Finally, is glacial drift, which is also sorting a few mineral size. So you can see that is like collovium as well. So normally, in terms of strength, probability, and deformity. So normally, if we have grade, this is weathering grade 1, 2, 3, 4, 5, 6. So normally 5, 6 and 5 is considered as soil. Grade 4 and 3 is characterized as a soil like rock or soil rocks. And then 2, 1, 2 is rock. And then before this, I said normally 1, 2, 3 is considered as rocks. 3 and 4 is considered as a soil. So this is the boundaries. Normally like this. Okay. So the strength is like this. So up to 500, 250 megapascal. So the higher grade of weathering, the strength will drop. Yeah. Similar to permeability, when you have low permeability for the rocks, because rock is not permeable, but decrease permeability increase to permeable, more permeable in these directions. But if you in grade 6, you have quite big range between permeability, high permeability and low permeability, because we have clay. If you have clay product, which is less permeable. If you have sand product, mean you have high permeable. So in terms of deformability, if you have low high grade it's a high grade of weathering, it's a soil, so we have easy deformation is high. If your rock is low deformation, yeah, it's because you have high strength, normally is low deformability. So this is a landscape of limestone. Show you this limestone shape looks like. It's a product of weathering. This is granite formations looks like. Different topography occur because of different material produced from limestone and granite. This is behind here is granite. This is limestone. Limestone, yeah, dissolve. Yeah. This. And at the end, we can conclude that the weathering, we have two types of weathering, called that physical weathering or mechanical weathering, or disintegration, called that chemical decompositions. So in chemical composition, change in their chemical decomposition of mineral change because of dissolutions, oxidation, and hydrolysis. Okay, they divide by 3. Hydration and hydrolysis will combine it. And then we have physical weathering, which are for wedging, crystal growth, thermal expansion, mechanical formation, roots penetration, and abrasion. So to conclude that, okay, thank you very much.